So I do either application oriented or infrastructure focused. Once I combine that, I can do that. Now, how do I like physically to show you? Let us say I have an application here and I have an application here. Now, typically, this is the virtual servers. Physically, I have only 1, 2, 3, 4, 5, 6. But virtually, these 6 servers operate as if there are about 6 into 5, 6 into 6, 6 into, yeah, about 36 servers. Even though physically I have only 6 servers, but they behave like a 36 servers machine. I can have 36 instances of operating system. 36 different applications or 72 different applications can be running on each of the operating system. Then I have these applications which are running separately. The first step is to combine the whole thing into a virtual environment. So everything becomes virtual. So now I can leverage the power of these machines for these applications, or I can leverage the power of these machines for these applications. So no single dedicated server for any application. All servers are available as a one big mainframe for me in my data center, and I can use based on my application requirement, I can use them. Then once I do that, I change the communication platform. You know, today we have multiple networks happening. So as a unified network. So I combine everything, I make it virtual, I make the whole thing as one single unified platform. One single unified computing platform for me. Now, how do I really see this? If you, just to give you one more detailed example, this becomes like a secured internal cloud, you know, within the data center. Now, if you look at it just as a diagram, how do you really make this happen? Now, first I have the 4 servers, 4 physical servers. On that, I was running all these applications. Now, the size shows the application size and the power required. Now, what exactly we are doing here is, let us say this application, you know, the small size means it's a smaller application, it requires smaller power. This means it's a bigger application, needs a bigger power. And some of the applications, based on their time, on month 1, on month 1, they may need a lot of power. Month 2, no power. So on month 1, they may look like this. On month 2, they may look like this. So dynamically utilizing the power of your computing platform for various applications. Let me just go back and show this again. So if you see this, the whole dynamic things which is happening, physically I have only 4 servers to start with. But since the applications were required less power, one of the applications from here, it moved here, and that space is used by additional applications. That's what we do. Now this is happening within one data center, within the room, right? Now you take the same thing and to the next level, where I have data centers in Singapore, New York, and Frankfurt, and I can seamlessly move an application from one data center to another data center. That is what is the your private cloud is going to bring to you. That's what is the thing which we have joined together to come up with this technology. Today, there are blueprints available. Blueprints are expected to be available sometime in September. We are working on it. The complete blueprint, how do you really get started? You know, blueprint is something like, it is like about a 60 to 100 page document we created step by step. What are the steps one needs to take to do it? So, in conclusion, cloud is the mean to change IT as a utility service. Maybe in 2050, this may be a reality. But it is going to get started. It is going to get started. It will impact first the enterprises before it impacts the public. See, today we have all our email IDs, yahoo.com or gmail.com or hotmail.com. We have everywhere, right? So we are confident that our mail is safe in a safe location somewhere in the cloud. But that level of confidence needs to come both for the consumers as well as for the enterprises to adopt fully cloud. Because that is important. Confidence is the important. Today we are confident I can always plug into any of the power socket and I can get power. So that level of confidence needs to come, but it's a start today. It's a start, it's coming to the maturity because we have very good networking happening, very good communication happening. That's why it is important for us to go on this. It's important for you to know about this because this is where you will be spending a lot of your effort, energy in doing research to make this happen, make this conference, make an application happen. And thank you for your time. You have any questions on this? Yes, sir.
Mr. Sharma, thank you for your excellent presentation. So for cloud computing, there are a lot of benefits, but I think the big problem or big challenge is the security as a pervasive.
Yes.
So how to solve these issues? How to guarantee the security and keep the information not leaked?
Okay. Now, what we are doing, EMC, EMC has a company, today if you look at security, a security company called RSA. RSA, what they do is today if you do a banking transaction over net, from your home, you want to look at your bank account. Now they say that you need to have the key fob, enter your security, and then put it inside. Now RSA is an EMC company. So we are building the security part of both for VMware as well as to have the cloud computing so that it is completely tunneled, secured communication between the two data centers. And also we are building it for the information itself. Every information at the field level, if a particular table needs to be accessed by only person A, then only person A can access it. Even though I take the table on my flash drive, I cannot access it because I'm not person A. And also, if you look at the new platform which Cisco has come up with, they have loaded the virtualization engine of VMware, which has the security. Now, today we can only do this on the private cloud, which is dedicated for an organization. Still, it is a concern for the public cloud, where we can use it. It is a concern today. So that is why we need to have a lot of security layers built inside, and that's where like research may happen, where institutes like yourself might come with a very special security algorithm, which encrypts and decrypts very highly. It's not 128 bits. I'm talking about like maybe 256 bit or 1024 bit algorithm, which you may need to come up with, which ensures authenticity and the security of the individual who is accessing the information and the security of the information. It's evolving. But for private cloud, we can do it today because of our RSA company, where we are focused on security. Thank you, sir. Again, it is new. The concept was, after grid computing, all those things, only in 2006, 2007, people talked about cloud computing. It was a real concept. And people are slowly coming up with 1 and 2 applications. Now today, it is coming to some level of reality for the private organizations, but again, it has to be a reality for the public organizations. For the public usage, it needs a little more time. Okay, thank you.